Hello students, we have seen in the previous video that classification is important because it makes the study of properties of as many as 118 elements easy. We know that scientists need to arrange the elements in a certain pattern to study the physical and chemical properties of the elements, their various processes, their reactions, etc. The first attempt to make these arrangements was made in 16th century AD. In the year 1817, Johann Wolfgang Dobereiner, a German chemist, tried to arrange the elements with similar properties into groups. At that time, 53 elements were known to scientists. This is quite a low number, isn't it? Yes, it is. But remember, we are talking about 200 years back in the history. He tried to place these elements into different groups, each having 3 elements. So, were these groups formed randomly? No, of course not. Dobereiner discovered that if 3 elements were arranged in ascending order of their atomic masses, the average of the atomic masses of the first and the last elements in this group is roughly equal to the atomic mass of the middle element. Remember atomic mass? It is the sum of numbers of protons and neutrons in the nucleus of atom. So if we take a hydrogen atom, it has 1 proton and no neutrons. Thus its mass is 1. If we take helium atom, it has 2 protons and 2 neutrons in the nucleus. So its mass is 4. Similarly, if we take carbon, it has 6 protons and 6 neutrons. Thus its mass will be 12. And for calcium, what will be its mass? Yes, it will be 14, since it has 20 protons and 20 neutrons. Now coming back to our discussion, Dobereiner arranged 3 elements such that the atomic mass of the second element is the average of the atomic masses of the first and third. He called each group a triad of elements because it has 3 elements, right? Yes. Let's understand Dobereiner's law of triads with examples. Consider the triad of sodium, lithium and potassium. Do you remember the atomic masses of these 3 elements? The atomic mass of sodium is 23, that of lithium is 7 and potassium is 39. Arrange them in their ascending order and we will get lithium, sodium and potassium with their masses like this. Now add the masses of potassium and lithium atoms. We get 46. Now to take an average, we need to divide it by 2 as we want average of 2 atoms. On doing that, we get 23, which is the atomic mass of the middle element sodium. Let's take one more triad. Consider calcium, strontium and barium. Their atomic masses are 40, 88 and 137 respectively in the increasing order. Remember, arranging them like this in increasing order is really important. We find that when we add the atomic masses of calcium and barium and take their average, we get an atomic mass of strontium. It is also true for other triads. Thus, Dobereiner discovered 5 such triads, in which he observed that if these 3 elements were arranged in their ascending order, then the atomic masses of the atom in the middle would be equal to the mean of the atomic mass of the other 2 elements. So you can ask, what is the big deal here? Well, it was a big deal at that point of time. We have to consider that all these attempts were made 200 years ago, where not much of science was developed and even not many elements were known. At that time, he could identify only few elements out of 53 that were known having similar properties and called them as neighbors. However, it was not possible to classify all these elements in this way. as they did not follow this rule. Out of all the elements, only 15 fit into the pattern. Thus, this method of classification was not perfect. Although Dobereiner's idea didn't work, but he has to be given some credit, as it was a start of an idea in a right direction. So now we have a view that masses of elements and their chemical properties are related somewhere. And how can we say that it was a start of an idea in the right direction? Okay, now take these triads and arrange them in the vertical rows and compare them with the modern periodic table. We see here that triads are present in modern periodic table also, or triads run in the vertical rows here. Let me show you. Consider the first triad, lithium, sodium and potassium, and go to the first column of modern periodic table. What do we see here? We see the same triads arranged in the same order here. That is lithium, below it sodium and potassium. Move one step to the right. We find the second triad of Dobereiner in the same order here. Calcium, strontium and barium. In fact, the third triad as well is found here. Move to the right side of modern periodic table and we find the triad sulfur, selenium and tellurium in the same order. Can you find the triad chlorine, fluorine and iodine? Yes, they are here in the same order as that of the Dobereiner in the column of halogen family in the modern periodic table. Now, since arranging all of the 64 elements in triads was not possible, Dobereiner was able to form triads of very few, specifically only 15 of them. With time, as newer and newer elements were found, the Dobereiner triads rule failed, and thus this classification was rejected. After Dobereiner's failure, the question of classification of elements popped up again. Now, on what basis can elements be classified? We will see this in our next video.